Determining the appropriate size for a grounded conductor, often referred to as the neutral conductor, in an electrical service is crucial for safety and compliance with electrical codes. For a 3200 amp 480 volt three-phase service with 500 mcm phase conductors, several factors in code sections come into play. The National Electrical Code, or NEC, provides the guidelines for sizing conductors and grounding systems. Understanding the relevant sections of the NEC is essential for ensuring a safe and reliable electrical installation. The grounded conductor carries the unbalanced current in a three-phase system and provides a return path for fault currents. The size of the grounded conductor is related to the size of the phase conductors, but it is not always required to be the same size. Several factors influence the minimum allowable size, including the service entrance size, the type of load served, and any applicable directing factors. Generally, the NEC outlines requirements for sizing the grounded conductor based on the largest ungrounded conductor or conductors. However, it is common to reduce the size of the grounded conductor relative to the phase conductors in larger services, provided specific conditions are met. This reduction is permitted because the neutral current is often less than the phase currents in balanced three-phase systems. For services over 1000 amps, the NEC permits reducing the size of the grounded conductor based on the calculated neutral load. The calculation must account for the maximum unbalanced load that the grounded conductor is likely to carry. The NEC provides methods for calculating this unbalanced load, and it is important to follow these methods carefully. When reducing the size of the grounded conductor, it must still be large enough to handle the available fault current. The NEC specifies minimum sizes for grounding electrode conductors, which connect the grounding system to the earth. The size of the grounding electrode conductor is based on the size of the service entrance conductors. These conductors provide a path for fault currents to return to the source, helping to trip over current protection devices and clear faults quickly. The NEC also addresses the sizing of equipment grounding conductors, which connect the non-current carrying metal parts of electrical equipment to the grounding system. The purpose of equipment grounding conductors is to provide a low impedance path for fault currents, minimizing the risk of electric shock. These conductors are sized based on the rating of the overcurrent protection device protecting the circuit. In many cases, the equipment grounding conductor is smaller than the circuit conductors, but it must still be large enough to safely carry fault currents. The specific requirements for grounded conductor sizing are found in NEC Article 250, which covers grounding and bonding. This article provides detailed rules for grounding systems, including the sizing of grounding and bonding conductors. It is essential to consult Article 250 to ensure compliance with all applicable requirements. The process for determining the minimum size grounded conductor involves several steps. Firstly, determine the size of the service entrance conductors. In this case, the service entrance conductors are 500 mcm copper. Secondly, calculate the unbalanced load that the grounded conductor is expected to carry. This calculation should be based on the type of load served in the expected load distribution. Thirdly, refer to NEC Table 250.102. See 1 to determine the minimum size grounded conductor based on the size of the service entrance conductors. This table provides guidance for sizing the grounded conductor for services up to and including 1100 kcmil copper or 1750 kcmil aluminum. Fourthly, verify that the grounded conductor is large enough to handle the available fault current. This can be done by consulting NEC Table 250.122, which provides minimum sizes for equipment grounding conductors based on the rating of the overcurrent protection device. Fifthly, consider any applicable directing factors that may affect the ampacity of the grounded conductor. Directing factors may be necessary if the conductor is installed in a high-temperature environment or if multiple conductors are bundled together. In this specific scenario with 500 mcm phase conductors, the initial step involves referencing NEC Table 250.102. Sheet 1. According to this table, for 500 mcm copper conductors, the minimum size copper grounded conductor is number 4 AWG. Therefore, based on the information provided and the NEC guidelines, The smallest size grounded conductor that can be run for a 3200 amp 480 volt 3-phase service using 500 MCM phase conductors is number 4 AWG copper. However, it is crucial to perform a thorough calculation of the unbalanced load and verify that the number 4 AWG conductor is adequate for the specific application. Consider factors such as voltage drop, fault current, and any applicable dirtying factors. If the calculated unbalanced load is higher than the ampacity of the number 4 AWG conductor, a larger conductor may be required. Additionally, local codes or regulations may impose additional requirements that must be followed. Consulting with a qualified electrical engineer or inspector is always recommended to ensure compliance with all applicable codes and standards. When installing the grounded conductor, proper bonding techniques must be followed. Bonding ensures that all metal parts of the electrical system are electrically connected, providing a low impedance path for fault currents. The NEC specifies the requirements for bonding, and it is important to follow these requirements carefully. The grounding electrode system must also be properly installed. The grounding electrode system consists of one or more grounding electrodes, such as ground rods, ground plates, or metal water pipes, that are connected to the grounding system. The grounding electrode system provides a connection to the earth, helping to stabilize the voltage of the electrical system and provide a path for fault currents to dissipate. The NEC specifies the requirements for grounding electrode systems, including the type and number of grounding electrodes required. Proper installation and maintenance of the grounding electrode system are essential for ensuring the safety and reliability of the electrical system. In addition to the NEC, other standards and guidelines may apply to electrical installations. These standards may include those published by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. It is important to be familiar with these standards and guidelines and to follow them when designing and installing electrical systems. Regularly inspecting and maintaining electrical systems is also essential for ensuring their continued safety and reliability. Inspections should be performed by qualified personnel and should include a thorough examination of all electrical components and connections. Any defects or deficiencies should be promptly corrected. Maintenance activities should include cleaning electrical equipment, tightening connections, and testing grounding systems. By following these practices, the risk of electrical hazards can be minimized and the lifespan of electrical equipment can be extended. In summary, determining the correct size of a grounded conductor for a 3200 amp 480 volt 3-phase service requires careful consideration of several factors in compliance with the NEC. While the initial assessment based on 500 MCM phase conductors points to a number 4 AWG copper conductor, a thorough analysis of the unbalanced load, fault current, and any applicable dirtying factors is crucial. Proper installation, bonding, and maintenance are also essential for ensuring the safety and reliability of the electrical system. Always consult with qualified professionals and adhere to all applicable codes and standards.